Hello guys, in this video we'll be looking at how to find mean and variance using characteristic functions on Poisson distribution. Mean and variance of Poisson distribution. Distribution using characteristic function. As we all know that characteristic function, so I will be doing the sum quickly without with a clear explanation. So follow with the flow. So what is q of x is defined with phi of x of t is nothing but the expected value of e power I t x. So we are doing for Poisson distribution, right? So we have to consider x is equal to 0 to infinity e power I t x. What is p of x into p of x? So what is p of x in Poisson distribution? That is equal to 0 to infinity e power I t x. P of x is nothing but the e power minus lambda power x by x factorial, right? So x term, so we have to combine them. So x is equal to 0 to infinity e power I t into lambda whole power x into e power minus lambda by x factorial. So e power minus lambda is a constant term, so get it outside. For minus lambda, sigma x is equal to 0 to infinity e power I t into lambda whole power x by x factorial. So I have already shown you that. So z power x by x factorial is can be written as e power z. So that is, it can be written as e power minus lambda into e power I t into lambda. So then later in the binomial if the binomial using MGF. So in the binomial using binomial function using a moment generating function, I have explained you that how we should write this formula and how we should divide the basic step. So I will write it directly e power lambda of e power minus I t minus 1. So I have quickly wrote it. So if you don't know how to solve this, just refer to my binomial using MGF video. There you can clear the solvation. So now let us find the raw moments. So what is the raw moment? Raw moment is nothing but the mean and variance. So what is the formula for mean? Mu1 dash is equal to mean is equal to first derivative order d by dt of phi x of t, right? Such that t equal to 0. So let us write the formula. So d by dt of e power minus lambda into e power lambda e power I t. So this is the equation I have taken here, such that t equal to 0. So what is the constant term here? Constant term is nothing but the e power minus lambda. So take it out and just solve to just try to solve for this. So for this also I have riff binomial using MGF video. So there I have explained how we have to solve for this one also in a small table, small column. So I will be writing directly. So e power lambda e power I t into lambda e power I t into I, such that t equal to 0. So if you refer my previous video, then only you will be able to understand why this step has occurred. Okay, or in case I will explain, no problem. So consider this term as m is equal to e power lambda e power I t. So let us y is equal to y be e power I t. So what is m? M is equal to e power lambda y. So let us define dm by dt is equal to, we have to define for two values, that is dm by dy into dy by dt, right? So differentiation of m, so we will be getting e lambda y into lambda y into lambda. Then what is the differentiation of this term? We'll be getting e power I t into y. So dm by dt. So that is the value we have got here, right? So this is a basic step. In exam, if you want just simple, you can try it, you can solve it there. So this is the equation for mu1 dash. So now let us substitute the t value, that is t equal to 0. If we substitute t equal to 0, what will happen? E power 0, that is we'll be getting e power lambda, and here we'll be getting e power 0, that is 1. So we'll be getting minus lambda into e power lambda into y. So what we have got, so what will happen? E power minus lambda, e power lambda will be getting cancelled. So we will be having lambda per n. So I have already told in my previous video that if in case if we have the I notation in the mu1 dash or variance, what we have to do, we have to take the imaginary values and we have to remove this I value. So let us do that. So what is the mu1 dash is nothing but the, so for it is mu1 dash, take the I value as the power 1, or if it is variance, we have to take the power 2 in this place of power 1. So what is d by dt phi x of t, such that t equal to 0. So what is minus I? What is d by dt value? Lambda per I. So we will be getting minus I into I will be getting lambda. So that is the mu1 dash. So what we got, mu1 dash is equal to lambda. So let us find the variance. So variance is nothing but the double derivative of the characteristic function. So what is the double derivative? So d square phi x of t by dt square is equal to d by dt. We already done the first order derivative, right? D phi x of t by dt such that t equal to 0. What is the first order derivative? So d by dt of what is the first order derivative here? So this is the first order derivative because we have didn't substitute the t value. So take this entire value, that is what is e power minus lambda into e power lambda it into lambda into e power it into I. So let us write this. So that is lambda into I into e power, we have e power minus lambda into e power lambda e power it into e power it, such that t equal to 0. Just let me verify it. Yes, it is entirely good. So now let us try to do that. So what are the constant terms here without the t value? Lambda I, e power minus lambda are the three constant values. So let us get outside. So lambda into I into e power minus lambda is the constant term, and we have to differentiate with these two terms. Consider this as u and consider this as v. So what is the formula? U dv plus v du. So we have to e power lambda e power it. What is the differentiation of e power it? Differentiation of e power it is nothing but differentiation of e power it into the power value, that is I, plus what is the v value? V value is e power it. So let us differentiate with respect to t. For the for this one we will be getting a, so what is the differentiation of u, this term? So we will be getting e power lambda e power it into lambda into e power it into I. Yes, entirely good. Such is t equal to 0. So hope you see, let me explain it. So we have to derive for this term, right? So e power lambda into e power it, just write it there. And now we have to derive for the, we have to differentiate for the power term. So what is lambda? Lambda is a constant term, so lambda into, so we have to derive for this term also, so the e power it. So what differentiation of e power it is nothing but the e power it itself. So now later we have to do for the power term also. What is the differentiation of it? So t will be removed and I, so I. So now hope you understand why did I write this step, such that t equal to 0. So let me substitute the t value also. T value directly, we'll be getting lambda into I into e power minus lambda, such that, so e power lambda into e power I 0 into e power I 0 into I plus e power I 0 into e power lambda e power I 0 into lambda e power I 0 into I. We will be getting, so lambda into I into e power minus lambda, such that, so this term will be removed, this term will be removed, then we will be having e into I power lambda plus this term will be removed, and here first term will be removed, e power lambda will be there, so lambda into I. So here what are the terms left with? Lambda into, so lambda into I into, here we have I and here we have e power lambda. So this is the term we have left with. So let us take this So let us from these two values. So from this equation we can get e power lambda as common, right? So is equal to lambda into I into e power minus lambda into I plus lambda I of e power lambda. You know that e for lambda and e power minus lambda will be getting cancelled. So what is the remaining term left with? So lambda into I of I plus lambda I. So get the I value also outside. What will be happen if I into I are multiplied? We'll be getting a minus 1, right? So minus lambda of, we'll be having 1 plus lambda. So that is the mu2 dash is equal to minus lambda of 1 plus lambda. So here we have done, here we got the item 1 plus lambda into I. So we know that I into I is nothing but root of minus 1 into root of minus 1 will be resulting to minus 1, right? So that is the we have done here. So we got this. Now let us try to find the variance. So variance is nothing but the mu2 dash minus mu1 dash whole square. So what is the mu1 dash? Mu2 dash is minus lambda of 1 plus lambda minus mu1 dash is we got as lambda. So lambda. So minus lambda plus lambda square. Oh, sorry, it's minus lambda square minus. So you can see that here we got as minus, right? So we have to remove this minus. So what is the formula then? We have to do with the imaginary values. So what is the imaginary values? So we have to do for mu2 dash is equal to this is for the order 2, right? So minus I whole square of d square phi x of t by dt square. So then later we will be getting minus I square of what is the dt square minus lambda of 1 plus lambda. So here what will happen, you will be getting minus 1 and here there is a minus, so will be combined and will be resulting to a plus, that is lambda of 1 plus lambda, which results to lambda square plus lambda. So mu2 dash is equal to lambda square plus lambda. So now we have to find the variance, right? So variance is equal to mu2 dash minus mu1 dash whole square. So what is mu2 dash? Lambda square plus lambda. What is mu1 dash is nothing but the lambda. So lambda whole square. So lambda square cancel, will be getting a variance of lambda, variance. So therefore mean is equal to variance is equal to lambda. So this is what we will be doing in the characteristic function of a Poisson distribution. So what we have done so far, we have seen the Poisson distribution using characteristic function. We have derived the Poisson distribution using characteristic function. We got phi of x of t is equal to e power lambda of e power it minus 1. So then later we went on finding the mu1 dash. So mu1 dash is nothing. Mu1 dash is the first order derivative of the characteristic function. So we have derived it. So I have explained. I have also shown you how to derive this step. If it is not clear, just refer my binomial using MGF video. There I have explained every step clearly. I hope it is clear to you. So no problem. So the mu1 dash is lambda into I. So just remember, in case if you get any I value or negative value in mu1 dash or mu2 dash, just use the imaginary values to remove I value or the negative values. So we have used that theory part here. So later when we got mu1 dash as lambda. So then later we went on moving the solving for the variance. In variance we have variance is nothing but double order derivative. So we have done the double order derivative and we got the variance as minus lambda of 1 plus lambda. So here we got as minus lambda. So to remove the minus lambda, we have to use the second order of negative values, imaginary values. Then later we went to the solvation. After that we get we got as mu2 dash is equal to lambda square plus lambda. So what is the variance? Variance is nothing but the mu1 dash minus mu1 dash whole square. Then we went on solvation. Variance we got as lambda. So we already know that in Poisson mean and variance are similar. That is the lambda. So that's all about this. That's all about in this video. Thank you.